Hello, Algebra 2. So today we're going to take a look at compound interest problems. So we're still looking at word problems with applications dealing with exponential functions. But again, today we're going to specifically focus on compound interest. So if you think back to the previous lesson, we use the function, the generic function, y equals a times b to the x power, where a is your starting amount, b is your growth or decay rate, and x refers to a lot of times time, the number of times this is occurring. So it says you deposit $1,000 in a college fund. So this is going to be your starting amount at $1,000 in a college fund that pays 7.2% interest compounded annually. Remember, annually means one time a year. It says find the balance after 5 years. So we're going to start with finding our growth rate. Hopefully everybody would agree that the amount in our college fund account is going to grow, not decay. So thinking back to the previous lesson, to find your growth rate, you're going to do 100% plus 7.2%, which when you add them is 107.2%. And then if you change that to a decimal for your growth rate, that would be 1.072. So plugging things back into my function, we're going to have y equals, my starting amount is 1,000 times my growth rate, which is 1.072. And again, how many times is this going to be compounded over the 5 years? It's going to be 5 times. So again, if I grab my calculator and type that in, I'm going to have approximately $1,415.71. So again, very similar to what we did yesterday, except maybe we're not compounding annually. We might be compounding quarterly, monthly, daily, things like that. Okay, now the second one, it says the same problem, only the interest is compounded quarterly. Okay, quarterly, remember, means 4 times a year. So if the interest rate is 7.2%, that is over the course of the whole year. So to figure out how much your what the percent is each time you're compounding it, you have to take the 7.2% and you have to divide it by 4. Because again, the 7.2% is over the course of the year. So you're going to take it in smaller chunks each time. So this gives you 1.8% each time you do it. So to find my growth rate, we're going to take 100% plus 1.8%. That's going to give me 101.8%, which as a decimal is 1.018. So back to my function here. So we have y equals, our starting amount is still $1,000. This time my growth rate is 1.018. I'm going to take it to the, okay, so if I think about it, again, it's over 5 years, but I'm doing it 4 times a year. So my exponent is going to be 4 times 5, which is the same thing as saying 20. Because again, I'm doing it 20 times. I'm compounding it 20 times over those 5 years. So again, if I type it in as 1,000 times 1.018 to the 20th power, I get approximately $1,428.75. So if I'm comparing the annually to the quarterly with the same percent, notice I'm gaining more interest. I have more money in my account. Okay, the more often you compound it with the same rate, the greater your balance of your account is going to be, the more interest you're going to earn. So we're going to do it one more time. Instead of quarterly or annually, we're going to take a look at it monthly. So if you're compounding it monthly, that means you're doing it 12 times a year. So to figure out our growth rate, we're going to take, first off, we're going to take 7.2% and we're going to divide it by 12. That is 0.6%. each time. So again, you're going throughout the year, it's 0.6% each time. So our growth rate, we're going to have 100% plus 0.67%, which is 100.67%. And if I change that to a decimal, that's 1.0067. So back to my function. I have y equals, my starting amount is still $1,000. My growth rate is now 1.0067. And I'm taking that to the 12 times 5 power, because again, I'm doing it 12 times a year for 5 years. So really, that's 1,000 times 1.0067 to the 60th power. And when I type that in on my calculator, I get approximately $1,431.79. So if you compare the three of them, again, if you're doing the same rate, you're going to make the most when you're compounding more often. So again, you're going to make more monthly than you would quarterly versus annually. We could do daily too. You'd have a little bit more in their account. Okay, so the next thing we're going to look at in the last part of the lesson is compounding it continuously. To the right page here. Okay, so for compounding continuously, we have a different formula we use. We have A equals P times E to the RT. So P is your starting amount, like our A value. We're going to do base E for continuously, and we've talked about that earlier in this unit. R is the rate as a decimal, not growth rate, but what the rate is as a decimal. And T is time in years. So in the first example, it says Hannah invested $820 in an account. Okay, so this is my P value. This is my starting amount. In an account paying an interest rate of 1.8% compounded continuously. Assuming no deposits or withdrawals are made, how much money to the nearest $100 would be in the account after 16 years? So if I think about my formula here, A equals my starting amount is 820 times E. Now my rate as a decimal, so 1.8% as a decimal would be 0.018. So 0.018 times T is the time in years, and we're looking at it for 16 years. So again, what I'm going to do is type this into my calculator. And when I do that, I get approximately $1,100 if I'm going to round to the nearest 100. I think it's like 1,093.6 something. So again, if I'm rounding to the nearest 100, that's going to be 1,100. Okay, if I look at the second example, we're going to take a little twist on things. So it says Aubrey invested $16,000. Okay, so this is your P value, your starting amount. Paying an interest rate of 5.6% compounded continuously. So we're going back to this P times E to the RT. It says, assuming no deposits and withdrawals are made, how long would it take you to the nearest tenth of a year for the value to reach $45,600? So you're looking for not how much is in the account, you're looking for how long it's going to take. So you're looking for your value of T, your time in years. So we want the account to reach 45,600. So we're going to say that's our A value. So 45,600 equals my starting amount, which is 16,000, times E to the RT, and 5.6% as a decimal is 0.056. So again, I'm going to have E to the 0.056 times T. Again, I'm looking for what's the value of T. So if you think about how we solved this the other day, so we're going to first divide both sides by 16,000. When you divide, it actually doesn't work out too bad here. This is exactly 2.85. And again, equals E to the 0.056 T. So if we're going to solve for T, okay, we're going to take the natural log of both sides. And remember, your exponent is going to come out in front. So we have the natural log of 2.85 equals 0.056t times the natural log of E. Now, the natural log of E is equivalent to 1. So if I have, again, the natural log of 2.85 equals 0.056 times t. So if I divide both sides by 0.056, my t approximately to the nearest tenth is going to be about 18.7 years. Now remember, parentheses are important. You need to make sure you close the parentheses here on the 2.85 before you divide by 0.056. Okay, so my last problem, we're doing a comparison. We are comparing Haley to Brooklyn. So it says Haley invested $95,000 in an account paying an interest rate of 7.25% compounded continuously. So she's compounding it continuously. We're looking at the I'm sorry, not P. A equals P times E to the RT. You can come in. I'm going to finish the video here. A equals P times E to the RT. So for Haley, your starting amount is $95,000. And then your interest rate is 0.725. So as a decimal, it's 7.25%. So it's going to be 0.0725. And the time it's looking at is 10 years. So if I do this first calculation, you end up with $196,149. If we compare that to Brooklyn, Brooklyn is also investing $95,000. But Brooklyn is paying an interest rate of 6.625% compounded monthly. So this is back to our Y equals A times B to the X power. So to figure out our growth rate, we're going to take 7.25% and divide it by 12. So that gives me 0.55. So again, to find our growth rate, we're going to take 100% plus 0.55. That's going to be 100.55%. As a decimal, that would be 1.0055. So I'm going to take, that's my growth rate, so 1.0055. And then to the, let's see here, what he said, monthly. So it's 12 times 10, because I'm doing it for 10 years and 12 times a year. So if I do this calculation, I get $183,473. So if I'm making a comparison between the two of them, obviously Haley's making more, but again, she's getting it compounded continuously. The question is, how much more would she have in her account? So I'm going to have to subtract them. So when I do that, Haley has more, or has $12,676 more. So again, you can see you're going to make more money when it's compounded continuously.